Hi everybody, I am Dr.T.Miranda Lakshmi, Assistant Professor, Department of Computer Science, St. Joseph College, Kadalur. In the last class, we saw about the different types of scheduler, that is long-term scheduler, short-term scheduler and medium-term scheduler. Today, we are going to see in detail about short-term scheduling policies. There are four types of short-term scheduling policies. The first method is round-robin method. What is the short-term scheduling? So last class itself we saw how the short-term scheduling will be working. We are going to dispatch a process from your ready state to your running state. Your running state is your CPU. So dispatching the process from your ready state to your running state is called as short-term scheduling. So when you are going to dispatch, it is going to follow any of these four methods, either round robin method or scheduling based on priority or priority method. We can say it as either scheduling based on priority or priority method, priority class method and heuristic scheduling. So these are the four methods. It will be dispatched from your ready state to your running state. The first method, round robin method. So if you're going to take your round robin method, it will be fully emphasizing your time slice. For each process, a time slice will be given. If the time slice expires, it will be joining the queue. So let us consider we are having four processes, P1, P2, P3 and P4. So if you're going to have four processes, if P1 has been executing, the P1 will be given 2 minutes of time. Similarly, P2 also will be given 2 minutes of time. P3 also will be given 2 minutes of time and P4 will be given 2 minutes of time. This 2 minutes of time is called as time slice. So time slice is nothing but you're going to allocate the time for each process. So here we are going to allocate as 2 minutes. But if you're going to take P1, it may take more than 10 minutes or 5 minutes. And P2, it also may take, just 2 minutes or it may take 5 minutes or 10 minutes. Similarly P3, similarly P4. But time slice says that you are going to allocate only 2 minutes for each process. So this method will be fully emphasizing on time slice. If the time slice is over, it will be joining your ready queue. This method we have seen and we have discussed already in your process state transition diagram. In your process state transition diagram, we have seen a method called as time up. So time up is a method which is being followed by round robin method. So when the time is up, the running state process will be switched to your ready state. So let us consider here an example. So we are having three processes, that is A, B, C. This is your CPU, that is your running state. Running state is otherwise called as your CPU. So current process is your C process which is being executed by your CPU. The next process is B. The next process is A. It is in a queue. So first process will be executed. Let us consider if I am going to give the time slice for the first process 2 minutes. It will be finishing and it will be joining the queue. Similarly, it will be going on proceeding according to the time slice. See next statement. Here the process C is executed in your first diagram. In your second diagram, we are going to see C has been joined here. What is the meaning of it? C has completed its job and it is being joined in the ready queue. Now A, B is present. B is being executed by your CPU. The next diagram. The next diagram, a new process X has been arrived. So what you are going to do is, you are going to add it in your queue. The next diagram says that B. So B is not been present in the next diagram. Where it has been gone? It may gone for an IO operation or it might completed the operation. Only two things it can happen. If B is not been present, B is not present in a round robin method, it may have gone for an IO operation or the process might be terminated. So here it has been mentioned, process B is terminated or involved in IO operation. So this is the procedure which we will be following it in round robin method. So you can see it here. So the ready process are in a single queue. We are having a single queue and dispatch them one by one. So each process has been dispatched one by one. The process which is in the running state gives off the CPU for the following reason. So when a process has been in your running state, already we have seen about what is my running state, what is your ready state process, and what is my block state process. So running state is your CPU. So from your CPU, why it will be coming out means due to these following three reasons. One, when the time slice expires. The other one, when the process is involved in IO operation. The other one is when the process is terminated. So for these three reasons only the CPU gives off. So we have seen this diagram. So if the process consumes the full time slice, the process state will be changed from your running state to your ready state. For example, if I have given us that 2 minutes time, so 2 minutes fully if it is going to use it, then it will be moved to your ready queue itself. That we have seen it in the first diagram. See here, C program is being run. After running, the process C has been completed fully, the full time slice has been completed. So it is being joined in this queue. This is your ready queue. Similarly, if the process is involved in IO operation before the time slice expires, I have given 2 minutes time. After 1 minute it has gone for an IO operation, then that process might be gone for a block state. So after the IO is completed, the process again joins the ready queue. So this is your round robin method. So round robin method fully is based on your time slice. Next you are going to see about your priority method. There are two types of priority normally. We will be saying it as internal priority. The other one is external priority. The internal priority is otherwise called as local priority, and the external priority is otherwise called as global priority. Internal. What is the meaning of internal? If the priority is given by the operating system at the time of process execution, then it is called as internal priority. If you are going to take your external priority, if the priority is given by the administrator or by the user at the time of process creation, then it is called as external priority, or you can say it as global priority. So if the priority is given by the system, that is your operating system, then it is called as local priority. If the priority is given by the administrator, then it is called as, it is a global priority, or we can say it as external priority. The next one is, this we have seen it already, non-preemptive scheduling and preemptive scheduling. What is non-preemptive scheduling? So if you are going to have in your running process, if it is a lower priority process, if a higher priority process comes and requested, the CPU will not be given. That is called as non-preemptive scheduling. The CPU will be holding this lower priority process until it is completed. The opposite of this is your preemptive scheduling. Preemptive scheduling means if the higher priority process is going to request the CPU, as soon as it requests, it gives up the CPU and gives way to the CPU, and it comes out of the running process. That is called as preemptive scheduling. The next method is your priority class method. So first method we saw about round robin method. So round robin method is based on your time slice. The second method is your priority method. In your priority method, we saw about internal priority, external priority. Then we saw about non-preemptive scheduling and preemptive scheduling. The next one is priority class method. So in this method, it will be splitting up into chains. See, let us consider in this diagram, we are having priority headers, priority 0, priority 1 and priority 1, 2. So here you are going to have your ready process. So this is P1, P2, P3, P4, P5, P6, any process will be there. What we are going to do it in this method is, according to the priority, they are going to split the ready process. Let us consider P1, P2, P3 is holding the priority as 5 and P4, P5 is holding the priority as 4. and the other one is holding the priority, less priority. According to that, it will be joining the ready queue. So first, all the three processes will be holding the higher priority. The next one will be priority 1. Next one, it will be priority 2. So the topmost queue will be your higher priority and the last queue will be your lower priority. So whenever a process comes with higher priority, it joins the ready process which is having the higher priority. Similarly, whichever the process which come for the lower priority, it will be joining here. So here inside this, we can use any method. Either you can use your round robin method or you can use your priority method. Any method can be followed here. See, let us consider this example. So if you're going to use, I already told that you can use your round robin method or priority method. So dispatch operation, it will be based on the priority. So the very important thing here you have to notice is, if your higher priority process, all the process has completed its job, then only it will be moving to the next queue. If this queue is empty, then it will be moving to the next queue. That is the main thing you have to know it in this priority method. So in this priority method, first it has to clear all this process. First it has finish all these process. Then it will be coming to the next priority. Then it will be going to the last priority. So even though if let us consider this process has arrived first, but these processes have arrived later, means the first preference will be giving only to the higher priority process. Later only it will be going on for your lower priority process. So the disadvantage in this method is, can you guess it? Indefinite postponement of the process. It will be indefinitely, it will be postponed. Thank you. The next class we can see about heuristic scheduling.